Hello, my name is Magali Redman, and this is my presentation on classifying quadrilaterals. I decided to look into this concept of classifying quadrilaterals and the importance of this concept in the future years of high school geometry. I currently teach third grade, and quadrilaterals are a big part of our curriculum, so I decided to learn more about the misconceptions and best practices of for our students to deeply understand and conceptualize the differences between quadrilaterals. The TEKS that I'm focusing on for this presentation are 3.6b, and that basically is where the students are classifying different attributes and they're expected to recognize the names of the shapes of the different types of quadrilaterals. And that was kind of the beginning TEK I focused on, and they will learn and use this concept all the way through geometry 6E, and the importance of knowing the attributes that define quadrilaterals that will build good foundation for future geometric expectations. So what we learn really young will really help us with those geometry TEKs. Okay, the goal for this training is to help teachers understand the importance of getting our younger students to develop a better understanding of the different attributes quadrilaterals have. By doing this, our students will have the skills they need to be successful in the future when having to make mathematical arguments for deductive reasoning and proofs. So I'll be talking about ways we can benefit our students according to 2 articles that I researched, and also give examples of some activities that could be beneficial. Okay. The first article that I read was What Difference Does It Make? Children's Views of the Differences Between Quadrilaterals. The reference is right here at the bottom of the screen. This article talks about student perspective of quadrilateral shapes and their conceptual knowledge about differentiating between them. They created a study with a group of 24 students between the ages of 11 and 12 years old, and their goal was to analyze the language the students were using to describe the differences between the quadrilaterals in order to help them see how the students were actually conceptualizing the shapes. And what they found out is that a lot of students knew how the quadrilaterals looked, but couldn't tell the attributes. And the students had one set prototype of a specific quadrilateral in their minds and only described that certain shape. This study also showed that written curriculum and textbooks put a mental image of certain quadrilaterals, and that became stuck in their brain instead of teaching like the attributes and the rules. So for example, a student that would know what it was, so they would know how a parallelogram looked, but they couldn't explain the differences it had from a rectangle. So they had some trouble in that. I learned from this article about the importance of breaking the typical mold prototype of drawing quadrilaterals, and it is more important to let the students explore than to just show that certain type of prototype. The second article that I read was pretty similar to this one. There's the reference right there. This article is called Learner's Level of Understanding of the Inclusion Relations of Quadrilaterals and Prototype Phenomenon. This paper studied the relation of quadrilaterals of past and present theories. They noticed that lots of students were having trouble distinguishing squares, rectangles, and rhombi as parallelograms. The students were stuck thinking of that stereotypical parallelogram that's slanted, like the green one on the screen. They composed a model and method to describe the learner's development of their understanding to classify the quadrilaterals. So they had 19 students that were in their first year of college, and they were also used 85 14-year-olds that were considered in the average range, and all of these people took a 30 to 40 minute questionnaire, and they realized that the students grasped the understanding of a parallelogram, but they couldn't accept a square or a rectangle as one. They also realized that the students thought that parallelograms didn't have right angles because they were stuck thinking of that slanted shape on the screen that you see. They also pointed out that the students understand not only the definition of a parallelogram, but also showing plenty of examples using. So in order to do that, we need to show more examples and less of that prototype. This next image that I'm showing you is something I found off Pinterest, and it was an activity that I saw, and this is kind of just like an example of an activity that probably won't be good to teach because you are matching up the word with the definition and then the shape. But under parallelogram, you know, they matched up that prototype, that same prototype slanted parallelogram, where a kid might say, well, a rectangle is a parallelogram. So I think these are the types of activities and types of things that we need to stay away from because it's confusing the students, and it's something to just think about as a teacher. Okay, tools for teaching quadrilaterals. Here are some things from the articles that I read and the class overall that I kind of put together. These are some things that you need to think about when teaching quadrilaterals, especially for students at a young age to build a good foundation for them. So the first one is let students explore a shape and take their time creating rules for that certain shape. So whether it's giving them manipulatives or having them sit down with a group and think about all the attributes that they can and writing their own definition and discussing it with you or with each other. I think exploring and really getting into that shape will help. The second one is to allow students to have conversations with you and other students about the attributes. Having certain conversations really helps because it allows you to think further and it puts more meaning in the activity. One big thing that I saw in both articles is that they said that we need to show examples and non-examples. So if we're talking about a parallelogram, we need to show that pictures of rectangles and squares and all sorts of different types of parallelograms, and then we need to show shapes that aren't so the student can differentiate. And another big thing that I saw was to stay away from memorization, just to stay away from just showing a picture and having them give a certain name. That we need our students to feel like it's a broader subject and that there are multiple names that they can call different figures. This next slide shows an activity that you can do with your students. It's called the quadrilateral family tree. I got this idea from one of the readings we had a couple weeks ago. It was from the article Quadrilaterals, Transformations for Developing Student Thinking. And one thing that stuck out to me was this quadrilateral family tree. And the article actually said that students can create a deeper understanding of the quadrilateral properties by creating a quadrilateral family tree. So if you look at this tree, I love how you can go in different directions. Like all the quadrilaterals are all together, and you can see how they like flow that way. And then they have non-quadrilaterals. So it really gives the student a chance to think through that sort of thing, and it shows a clear picture that a quadrilateral is more than just that slanted shape. This will help the students show and demonstrate their understanding of a quadrilateral. So whether it's you giving them the vocabulary words and they are supposed to create a family tree either on a whiteboard or some on an iPad, or they can just draw it out themselves. And I think it'll bring up a lot of conversation, and it'll help you see also misconceptions or how they really feel about the different shapes. One thing that I do use, a strategy I use in my classroom, and I think it goes along with my concept, is that I teach this game. I kind of made it up. It's called the How Many Names game, and the students love it. So what I would do is it would be kind of a warm-up before we start a geometry lesson. So I would throw a shape up. So in this scenario, I would put this green shape up on the board, and I would have the students either on their whiteboards or their math spiral write as many names as they can to call that certain shape. So they could call it a square, a rectangle, a quadrilateral, a parallelogram, a polygon, a regular polygon, a rhombus. Like, they would have to come up with as many as they could. And then they get with their group and they share what they think. And, sometimes there are words that it's not, and they have that meaningful conversation. Sometimes there's words that they forget, vocabulary words that they forget, and that also brings out meaningful conversation. And I just walk around the classroom listening in on what they're talking about and making sure I clear up anything. And then as a whole class, I put up all the vocabulary words that they could have found. And they love it. They think it's a game, and I think it's also a really good assessment. Okay, this is the end of my presentation. I hope you learned a lot from it. Just keep this in mind next time you are teaching students about quadrilaterals, so they have that good foundation for the later years in geometry. Thank you.